Okay, number 87 has a board that's supporting. It's got a board supporting a 6 kilogram box, and the 6 kilogram box. What I did was I took 9.8 times 6, and that's the weight of the box. Then here I have the weight of the board, and what I have is the person on the right lifting up. I just call the force on the right, and the person on the left lifting up. So here's my forces that are acting on it. And what I did, they gave me a bunch of distances, but what I like to do is the middle of the board is, the whole thing is 1.75, so I just divided it by 2, and that's the distance to the middle force, and that's 0.875. And then they tell you that this is 0.5 from the end of the board to the middle of the box, and then so I just figured that out. I took this plus this, and I subtracted that sum from 1.75, so I figured out that this distance has to be 0.375. Now you don't have to do that, but I like to do that. So we have two unknowns. We don't know the thing on the right, and we don't know the thing on the left. So what we're going to have to do is come up with two equations. So this thing is in equilibrium. And when it's in equilibrium two ways. It's in equilibrium rotationally, and it's in equilibrium force-wise. And force-wise, what it means is everything that pulls down has to equal everything that pulls up. So the things that pull down are the 41.7 and the 58.8. And the things that pull up are the force on the right and the force on the left. So I mean, when you add these two together, 41.7 plus 58.8, you get 100.5. I mean, I don't know what it is, but like if this thing turns out to be 50, this one's going to be 50.5. If this one turns out to be 1, this is going to be 99.5. They have to add up to 100.5. So we don't know. This doesn't tell us what they are, but it does tell us how they're related. So now what I'm going to do is go over to the rotation side, and I'm going to say that everything that torques this thing clockwise has to be equal to everything that torques this system counterclockwise. Now when you do this torque problem like this, what you're going to have to do is you have to pick a spot for it to be where you want the center of rotation to be. So pick your pivot point. So normally what I recommend you do is pick the pivot to be right on one of the unknown forces. So this is where my pivot, I'm just going to pivot it right there. So when I look at this force cranks this thing that way, and that is a counterclockwise moment. So I take the force times the distance. So this force is 58.8, and it goes on this side too, because this is the counterclockwise side. So torque is force times distance, so 58.8 times the distance, and the distance is 0.5. So that's that one. This one cranks it the same direction. This force pulling, if it could pivot here, this one would pull it down in that direction. So the force is, so that goes on the same side, 41.7, and the distance is, you have to add those together, 0.875. And now I've got this one over here. This force this is the only force that's cranking it the other way. This is my clockwise moment here, my clockwise torque. So I'll put that one on this side, and the force is unknown, and the distance away from it is 1.75. So you can see why I broke these down, because it makes figuring out the distances between it a lot easier. So that's why I always fill in the gaps. So now we've got, I've got two equations with two unknowns. So what I'm going to do is I'm going to solve this equation right here for L, and then whatever I get, I'm gonna stick it in here, and I can solve for the right one. So it's gonna be just algebra from here on out. So I'll take let's see here, 58.8 times 0.5 plus 41.7 times 0.875, and then I divide that by 1.75. So the left one equals 37.65. So then I'll take this, and with substitution I'll put this in. The force on the right plus 37.65 is equal to 100.5. So I basically take, so the force on the right, 100.5, subtract it, and I get 62.85. Now, with significant figures, I should probably go the force on the right is equal to 62.9 newtons, and the force on the left is equal to 37.7 newtons.